So in this problem, we want to find the equation of a tangent line that is tangent to the graph y equals x cubed and also parallel to 3x minus y minus 4 equals 0. So if they're to be parallel, then what we need is the slope of this line, because we need to know what the slope of this line is going to need to be. So let's start off by finding that slope. Easiest way to do that is to get this into slope-intercept form. Basically solve it for y. So I can do that real quick by adding y to both sides, and I get 3x minus 4 equals y, and I now have my m. Remember the mx plus b form? There's the slope. So that's the slope of the tangent line because we want it to be parallel to this given line. Now we need to find the tangent line. So to find a tangent line, remember, we need two things. We need the slope and a point that it goes through. Now to find the slope of a tangent line, well, we need the derivative of our function. So we need y prime, we'll call it, or we could call it dy dx, whatever notation you like. And we have a power function. So using our power rule, y prime is equal to 3x squared. Now we know that we want 3x squared to be equal to 3. We're basically getting our two slopes equal to each other. Now the reason I'm doing this is we have to find out the points on y equals x cubed where the slope is going to be 3. Now if I solve this, I divide both sides by 3. I get x squared equals 1. Square root both sides, and I'm going to get x equals not just 1, but it could be plus or minus 1. So that tells me that on the graph of y equals x cubed, there are two places that the tangent line is going to have a slope of 3. One at positive 1, one at negative 1. So if we want to take a look at what's going on here, let's put in our graph of y equals x cubed. Bear with me, this is a hand-drawn graph. So we're having one tangent line here, and we're having another one over here. So we're actually going to have two answers to this problem. One with an x value of positive 1, and one with an x value of negative 1. Now, two things we need to find a tangent line, or any linear function: the slope and a point that it goes through. We already know that the slope for both lines is 3. And we know the x values for both lines. One of them is 1, the other one is negative 1. Now, what we need is the y value. Well, we go back to the original function for that. So y equals positive 1 cubed, which is 1. So that gives us this y value. So we have our point and we have our slope. Let's go ahead and do this in point-slope form. Y minus the y value equals the slope times x minus the x value. And that's our line. Now if we wanted to convert this to slope-intercept form, we distribute the 3. So that gives us a 3x minus 3. And then we add 1 to both sides. So one of our tangent lines is the line 3x minus 2. We have one more tangent line coming. It also has a slope of 3. Now it's got an x value of negative 1, so we're going to put that into x cubed, so negative 1 cubed is negative 1. So negative 1, negative 1. We'll do this one starting off in slope-intercept form just so you can see the difference. In this case, we would start to set it up. Y equals 3x plus b, and now we're going to plug in this point to figure out what b should be. We know that when y is negative 1, x is negative 1. So negative 1 equals negative 3 plus b. And there's going to be a lot of symmetry here. add 3 to both sides, and we get b equals 2. So the other solution is y equals 3x plus 2. Sorry, my marker's not working so well. 3x plus 2. And there are our two tangent lines.